Hi everyone, Siddharth here. This is the sixth session in the series of Spark. And in today's session, we are going to talk about the type of joins, broadcast joins, and shuffle sort merge joins. Just before we get started, we should all know that join is an operation that leads to shuffle. And shuffle is a concept that we have discussed in a previous video in the same series. So if you've not watched that video, please feel free to watch that before coming in here. So let's get started with the code. The first thing we need to look at is the data set. So it's the same data that I have used throughout the series. You have a short name, which is the name of the stock on NASDAQ. You have a date and you have the end of day stock value. For example, AAC is a stock name. And on 1st of January 2016, the value of the stock by end of day was $19.06. Now, let's go to the next block. Now we have another data set which is kind of connected to the previous data set. This second data set is called as metadata data set. Now let's see what this data set is all about. Let us do a display of metadf. So in this data set, in the second data set, I just wanted to look at the first two columns, which is short name and full name. So what is happening is the first data set that we saw has a short name of the stock on NASDAQ, and the full name of the stock is present in the second data set. So the column which connects the two data sets is short name. So that is the column that we are going to use our join for. Let's see what we are doing in the code. So the first thing that we need to figure out is what is a broadcast join and why it is called as broadcast. So first thing first, let's look at the concept. So when you have a small data frame, when you say small, it means a data frame that can fit in one machine. Spark is a distributed data set, distributed architecture. So that means your data will be fitting into multiple machines. But if you have a small data frame for data for which is sitting in one single machine, that can be treated as a small data frame. And you have a big data frame that is fitting in multiple machines. You want to join these two data frames. In that case, you can use a broadcast join. What is the meaning of broadcast? The meaning of broadcast is instead of doing the basic shuffle operation that we have seen in video number 4 of this series, we are going to do something very different. We are going to take the small data frame from the slave machine and driver is going to pick it up. So driver node will pick this data frame and then will broadcast this data frame, the small data frame, into all the slave machines. Simply means driver takes the small data frame from one of the executors and it sends that small data frame to all other executors. So that means the data will not be shuffled between multiple executors. Rather than that, the small data is just taken over by driver and driver sends it to all the other executors which have big data frame data set. So that was about broadcast run. Now we have the exact same problem. We have a small data frame and we have a big data frame. Now, if we try to do a join, it will do a broadcast join. And I've already written the SQL query and the explain plan as well. So this is the two tables getting joined on short name. I'm doing a where clause on one of the full names just to show you one concept. And I did a explain. So explain will tell me the explain plan. The plan is here, but I executed it before and copy pasted the plan here for ease of understanding. So one thing to note is in the explain plan, you see something called as broadcast hash join. So this means that we are using a broadcast hash join in this join condition. The second thing that you need to note is something from our previous sessions, which is filter push down. When you're using a where clause, there are high chances that the filtration can happen at the source, and that is displayed in the explain plan using pushed filters. So if you see here equal to ALCOA inc, right? So your filter clause is getting pushed to the backend and not getting executed in Spark, which is a good sign. So let's get to the next code, which basically executes this data frame or this join condition. Till the time it is executing, let us go to the logs. So we want to open Spark UI. Okay, it got executed. So we have the output of join. We just wanted short name and full name in the select. That's what came in. But that doesn't matter. What matters is we are joining on this condition and it is a broadcast join. So there is something specific I want you to see in the logs. You need to go to SQL data frame. Let's see if this is the one. Yes, this is the one. Yeah. So you see here, there is something called as broadcast hash join, right? Written in the logs. So you got your data, your CSV data that was pushed into an exchange. Exchange is nothing but RAM, right? A broadcast RAM. And that was broadcasted to all the other slave machines, right? So this is what your broadcast join was all about. Now let us see something very interesting. You can actually see something called as a join ambiguity here. What is join ambiguity? When you are joining on a data, two data frames that have a same column present. For example, in both of these data sets, we had short name present, right? So I did first data frame dot join. So this, by the way, is a column expression kind of a statement. And I'm not using Spark SQL here. So I joined the two data frames. I gave the condition which was to be used on joining, which was a short name, and it's an inner join. I selected short name and full name. But Spark got confused that from where you're going to pick short name. Are you going to pick the short name from metadata data frame, or you are going to pick data frame from short name from the previous data set? So it got confused and it asked you that short name is ambiguous. You have to pick the short name from one specific table. It is present in two tables. You have to make that ambiguity go away. So how do you make that ambiguity go away? It's very simple. Once you do the join, after that you drop the short name from one of the data frames. So I dropped it from the first data frame, and now it is available only in the metadata data frame. That's why when I used it in the select, it did not give me any error. That was about the join ambiguity. Now let's see something called as shuffle join. So we discussed the concept of shuffling before. Shuffling is the concept that creates a performance bottleneck in Spark. Now we can actually force a join, which was happening as a broadcast join before, to become a shuffle sort join. This is done just to show you the concept, but in reality, broadcast joins are better, and we normally try to convert our shuffle joins into broadcast joins, but we never try to convert our broadcast joins to shuffle joins. So there is a setting in Spark which is to do with the data size limit with which you have to have a broadcast join. For example, the default setting is if your small data frame is less than 10 MB and your big data frame is greater than 10 MB, in that case, do a broadcast join, right? So your small data frame is less than 10 MB. So I do a broadcast join. So what I'm doing here is I'm changing the setting auto broadcast join threshold to 1 KB. So now what I'm saying is if my small data set is less than 1 KB, then only do broadcast join. Otherwise, just go ahead and do a shuffle join. This is wrong. This should not be done, but it is just done to show you the concept and the setting which is there in place. So I'm using the exact same query as I had before. There is nothing that has changed. Let me just execute this condition. And then let me just do the explain plan again of the same query, exact same query. So plan is here, but I've copy pasted in the cell for ease of understanding. So you can see the previous cell was showing broadcast join. Now it is getting converted to a sort merge join, right? So exact same query got converted. This is because I'm using a shuffle sort join setting, which is here, which is what I explained, which is pushing a broadcast join into a shuffle sort join. So now what is a shuffle sort join? Let us also look at the logs. So let it execute. Once it executes, we will see the log file and we'll try to figure out what exactly is happening within the logs. Yeah, so this is what I was talking about. Now you see that there's something called a sort. So basically you have two different machines, or you have two different areas which are transferring the data, and then you are doing all that shuffle sort again. And then there is something called as sort merge join. If you're not clear with the concept of shuffling, that concept we discussed in session 4 of this series, please go through that. You'll figure out the idea behind the shuffling, right? So this kind of concludes the topic of shuffle, sort, merge join, and the broadcast join. Let us just briefly see a concept of AQE, which is adaptive query engine. So what is AQE? AQE is a new setting that has come into place. Using this setting, there are multiple things that you can do. One of the things that we can cover in this session is to do with shuffle partitions. So what is a shuffle partition? When you are doing a wide transformation, in that case, shuffle is happening and your number of partitions get converted to the default 200. So 200 is the default partitions, which is configured. It's not the partitions in the backend, which we discussed in one of the video before. That was using a clause called as partition by. That was when we write the data to the backend. This is to do with your data frame partitions in the RAM. So it gets converted to 200 partitions when you use wide transformation. But in few scenarios, 200 is the default value. You can modify that. You can hard code that value to anything you want. Now, you do not have to convert every data frame into 200 partitions after a wide transformations, because data frames could be small. There could not be 200 categories also available, but still you're pushing them to convert it to 200 partitions. So that is what this concept of AQE comes in. So that's what it's written here. The default shuffle partition is 200. It kicks in once you do a wide transformation to an existing data frame. So what I've done here is I have disabled the adaptive query engine as of now. I've done it false just to show you that 200 partitions are happening. And then what I have done is I've just printed out the default shuffle partitions, which is 200. And then I did a wide transformation, which is distinct on the input data frame. Once I do a wide transformation, my data frame, which might be having, I think, 4 partitions, as I've seen in the beginning, gets converted into 200 partitions by default. That's the default setting. Now, how do we change this behavior? We can change this behavior by two ways. One way is we can change this default setting from 200 to 10. Right? And now when I do the count or the distinct, which is a wide, not count, distinct, which is a wide transformation, in that case, my number of partitions do not get converted to 200, it gets converted to only 10. The same concept can be achieved through AQE. So if you don't want to hard code any number of shuffle partitions, you can just enable AQE. So I just enabled adaptive here, and I again did the same wide transformations. Once I did the wide transformation, it did not convert it into 200, it did not convert it into 10, it overrides all the hard-coded values of the shuffle partitions, and it is going to convert your wide transformation data frame into just one partition. That's what it thinks it should, right? So that's an intelligent optimization that has been done. There's no hard coding required now on the number of partitions that your data frame will have after wide transformation. You don't need to hard code the number of partitions. AQE will determine on its own and will come up with the number of partitions that it should have based on the data quantity. So that's all for today's session. Thank you all for joining. Have a great day ahead. Bye-bye.